Let me show you the tutorial. The tutorial sheet for today is this one here. This is the tutorial sheet for today. So can you start working on question 1, please? Question 1 is not, I mean, both questions are not difficult. So you have the standard GEV distribution, and we want to find the PDF. So this is the CDF, as you know. So we want to find the PDF corresponding to the CDF. Okay. So can you take a few minutes since you can do this? Then I'll show you how to do it. Okay, guys. Not many people are today. How come? Right. Let me change the camera and start doing question 1. So this is question 1. All right, let me show you how to do question 1. I'm sure you've done it already, but if you haven't done it, then let me show. Hello, guys. Hello, are you there? Okay. All right. So let me show you how to do question 1 part, starting with part A. Okay. So part A is to find the density function PDF. So to do that, you just simply have to. Sorry, excuse me. I'm having trouble with the video. Excuse me. You have to just simply differentiate the CDF with respect to X to find the PDF, right? And if you do that, this is what you will get. All right, this is what you will get as the answer for part A. Part B is to find the nth moment. Right, to find when I say the nth moment, I mean, what I mean is the following. I mean the expected value of x power n, right? This is what I mean by the nth moment, right? So if you have any questions, guys, just use the chat room. So this is defined, I'm sure you guys know, this is defined as the integral of this with respect to x, right? Now, we need to consider, because remember, psi can take any value from negative to plus infinity. And when I talked about the GV distribution a long time ago, I told you that the range of the density is different depending on the value of psi. Okay, so for example, so let me first consider the case psi is greater than 0. In this case, the range of possible value for x, right? In this case, the range of possible values for x are from -1 over psi to plus infinity. I think you should look back in the notes for when I talked about the GEV, the generalized extreme value distribution. I talked about the fact that depending on the value of psi, the domain of x is different. So when psi is positive, this is the domain for x. All right. So in this case, the integral will be from this to this of okay. All right. So you need to do this integration. Obviously, to do this integration, you need some kind of substitution. So let me use the following substitution. I mean, there's no magic rule about what substitution to make. This is something you need to learn by experience, right? So if this is the case, then okay. So x will be this, and dx by dy will be this. All right. Furthermore, when x is equal to -1 over psi, right? When x is equal to -1 over psi, right? Y will be equal to, so if you put -1 over psi into this, right? You will get 0 to the negative power, because we are assuming that psi is positive, right? So 0 to the negative power is infinity. So y will be infinity. And when x is infinity, y will be 0. All right. Okay. So that's all. So let me put this whole thing here. Let me put this inside a box. All right. Let me put this inside a box. Okay. So what I'm going to do now is I'm going to substitute this into the integrand, right? And if you do that, you will get the following. You get infinity to 0 of right? Okay, and this a lot of things here will cancel out, and I'm going to use the negative. You see, there's a negative sign here. I'm going to use that to change the limits around. So whenever you multiply an integral by a negative sign, you can change the limits, and it will the above integral will simplify to this. Okay. All right. Now, in the next step, I'm going to use the binomial expansion. I'm sure you guys know what the binomial expansion is. I think I talked about it before in this course. If you don't know what it is, let me write it down. If you have something like this, right? B plus a power n, then you can write it like this, all right? And this is known as the binomial theorem. I think you probably know this already. Okay, now if you use this theorem for this term here, you will get the following. Okay, this is what you will get, right? Applying the binomial theorem to this term here. Okay, now you can take the integral inside the sum, and that will give you the following. Right? All right, now this integral should be familiar to you. This is basically a gamma function. I think in case you forgot what this integral is, let me write it down, the definition of gamma function one more time. So the gamma function is defined as this, right? So this is, I gave you this, I mean, I did a video on the gamma function, you may recall. You should go to the course website, you will see a video on the gamma function, right? So using this definition, using this definition, you can complete the you can have this. So you will have okay. So this is what you will get for the nth moment. So this is only, let me remind you, this is only if psi is positive. Now we need to consider three cases. We need to consider, so the second case we need to consider is where psi is less than 0. In this case, if you look at the notes, I mean, that I gave you, if you look at the videos I gave you, you will see that in this case, the range of x, or the domain of x, is from minus infinity to this, right? The domain, when psi is negative, this is the domain for x. This is in the video on the GV distribution. You should look at it, right? Now, you can do the same calculations, but I'm not gonna, because you may have other questions. So I'm not gonna, similar calculations. So let me just write it here. Similar calculations to the above show that the expected value of x power n in this case is equal to right? It's actually the same as this. These, you see, these two formulas are the same. So you get the same formula for the expected value of the nth moment. The nth moment for psi greater than 0 and less than 0 are the same. These, as you can see. All right, the third case, the third case I'm going to consider is where psi is equal to 0. Now, this is the case where the Gumpel distribution reduces to the Gumpel, the GV distribution reduces to the Gumpel. So in this case, the CDF of fx, which is the CDF I gave you in the question, it reduces to the Gumpel. I think I proved this in the class some time ago, you may recall. And the PDF, which is the derivative of this, is equal to this, right? So what we need to find the nth moment, and also the domain for x. The domain for x is from minus infinity to plus infinity. All right. So to find the nth moment, what we need to do is we need to integrate from minus infinity to plus infinity of this multiplied by the density, which is this. Okay. And in this case, the obvious substitution is to make y equal to this, right? So x is equal to minus log of y. So dx by dy will be minus 1 over y, right? And also when x is, let me say this, when x is minus infinity, y will be equal to plus infinity, right? And when x is plus infinity, y will be equal to 0, right? Okay, now let me put this in a box. Right? Okay, so I'm gonna do the substitution right now. So I will get, you see what happens in a minute. Excuse me. if you make the substitution, you will get this equal to infinity to 0 of okay, this is what you will get. All right, now there is a minus here. So I'm going to use this negative sign to change the limits around from infinity to 0 to infinity. And there is also minus here. So I'm going to pull out the minus outside. There's going to be minus 1 to the power n, the integral from 0 to infinity. And by the way, these two guys cancel. So you get log of y power n e of minus y dy. Okay. All right, guys. Now, you may recall one of the formulas, I mean, I did this long time ago, you might have forgotten. One of the tricks I gave you, I think I did a video on this too. This is known as the trick, differentiation trick, that you can write this guy here as follows. Do you guys remember this trick? I mean, I did, there's a video on this trick. If you go to the course website, if you go to the course website, you will see a video about this, right? Okay, so this becomes okay. Okay. Now I'm gonna take the operation of the derivative operation outside the integral. So I'm basically switching the integration with the differentiation sign. So this will become okay. This becomes like this, and finally this becomes. Now you recall this integral is the gamma function at a plus 1. So this is okay. So this is the expression for the nth moment in the case psi equal to 0. So we have derived the expectation of x to the power n in all three cases, right? So just to summarize, let me write this. So what we have shown the following. We have shown that this guy, the nth moment, is equal to one of the following. Is equal to this if psi is not equal to 0, that is either greater than 0 or less than 0, and is equal to if psi is equal to 0. So this is the answer to part B of question 1, right? Now to do part C is asking you for the mean, the expectation of x, which, I mean, remember the mean is the same as the expectation of x, right? So to find the mean, all you have to do is just put n equal to 1 into this and n equal to 1 into this. So if you do that, you will get two different answers. One in the case where psi is not equal to 0, one in the case when psi is equal to 0. So when psi is not equal to 0, if you put n equal to 1, you will get this. I think, correct me if I'm wrong. Right? And if you put n equal to 1 into this, you will get minus gamma prime. Prime means derivative. Okay, so this is the answer to part C of question 1. And finally, part D. To find part D, if you have any question, just please feel free to use the chat box or use your microphone. Either way is fine with me, right? All right. Part D is to find the variance. Is to find the variance of x, right? So that's the same as, I'm sure you guys know this formula. Okay, this is the formula for the variance of a random variable. All right. Now we know what this guy is. We already worked it out. This and this. To find this, all you have to do is you have to put n equal to 2, n equal to 2 into this formula, right? So if you do that, this is what you will get. Once again, you have two different answers. If you put n equal to 2 into the formula that I mentioned, you will get this. And the square of the mean, which you already worked out, is equal to is this. Sorry, this is squared also, right? That is if psi is not equal to 0. Now, if psi is equal to 0, then if you put n equal to 2, you will get this denotes the second order derivative of the gamma function at 1, right? Minus the square of the expectation is okay. So this is the answer to part D of question 1. All right, so it completes question 1. Now, before I start question 2, do you have any question, anything you like to ask me on question 1? Please let me know. Hello, guys. Anything you like to? Is there anything which is not clear to you? Please let me know. Hello. Are you guys there or not? Can you hear me? Yeah. So any questions on question 1? Okay, thank you. All right, so let me move to the next question, which is question 2 of the sheet. So question 2 is about the generalized Pareto distribution, which is given by this CDF. This is the This is the CDF of the generalized Pareto. So the first part is to find the PDF. So to find the PDF, you differentiate the CDF, right? So if you differentiate this guy here with respect to with respect to x, you will get this, right? All right, that's part A. Now, part B is to find the nth moment, all right, which is equal to the expected value of x power n, which is equal to the integral of x fx dx, right? Okay, now once again, this is the shape parameter, which can take values from minus to plus infinity. So we need to consider the three different cases. So let me start with the case that psi is positive, right? In this case, you should look at the nodes. I mean, there's a video I did on the generalized Pareto distribution. Right now, in that video, I showed you that if psi is positive, then the domain for x is from 0 to infinity. If you go back and look at the video, you will see this. If you have positive shape parameter, then the domain is from 0 to infinity. All right. So the expected, so this integral will become 0 to infinity of this. Okay. All right. Now we need to do some kind of substitution. So in this case, the obvious substitution is to set y equal to 1 plus this, yeah. So this implies that x equal to y minus 1 divided by psi. So dx by dy is equal to 1 over psi. And furthermore, if you put x equal to 0 into this, you get y equal to 1. And if you put x equal to infinity into this, you will get y equal to infinity. Right? All right, let me put this in a box. Okay, now I'm going to put this here. So the limits of integration are from 1 to infinity. X is this, okay, x to the power n, and then you have y, excuse me, okay. Now if you simplify this, you will get this, yeah. Now I'm gonna use the binomial theorem, which I gave you a couple of slides ago. I talked about the binomial theorem. So I'm gonna use that to expand this term here, right? So if you do that, you will get this is 1, guys. All right, so you will have this in a box multiplied by this, right? Okay, guys, let me know if you have any questions. So right now you can take the integral inside the sum, and if you do that, you will get you will get this, right? Now the integral of this is not difficult, so let me show you. So if you integrate this with respect to y and take the limits, this is what you will get. You will get um, you will get y. Okay. At infinity, if you assume that k is less than this, then at infinity this will be 0. At 1, it will be 1 divided by this. So what you have is the following. So assuming that this is a negative number, this will simplify to 1 divided by 1 over psi minus k. So this is the expected value of x power n when psi is positive, right? Now the second case that we need to consider is psi is less than 0, right? And in this case, if you look at my video on the GP distribution, the domain for x is from if psi is negative, then the domain is from 0 to minus 1 over psi. This is in the video I showed you earlier on the GP, right? Okay, so in this case, the expectation of x power n will be from the integral from 0 to okay, it will be this. Now I'm not going to do the integration, but I'm sure you guys know. I'm sure you guys are all experts on integration, and if you work this out in the same way as I did this one, right, you will get the following. right? This is what you will get, which is the same as this. You see, these two formulas are the same, although the sign is different. They give you the same answer, right? Okay. Now, finally, we consider the case where the shape parameter is 0, right? Okay, in this case, I think I showed you if when psi is 0, the generalized Pareto distribution reduces to the exponential distribution, which is this is the CDF of an exponential. I'm sure you guys know. So therefore, the PDF is the derivative of this, which is this. So the expected value of x power n, and by the way, the domain is from 0 to infinity, right? So the expected value of this is 0 to infinity of this, right? Which I'm sure you guys all know. This is a gamma function at n plus 1. And one of the properties of the gamma function is equal to n factorial. I mean, if you look at my video on the gamma function, you will see this, that gamma at n plus 1 is equal to n factorial, right? So we're done with, so just to summarize, let me summarize. So the nth moment of x takes two different formulas, right? The first formula is this is the first formula. That's when psi is not equal to 0. And the second formula is n factorial, as if psi is equal to 0. All right, so this is the answer for part B of question number 2. Now part C is to find the mean, which is the same as the expected value of x. So all you have to do is just put n equal to 1 here and n equal to 1 here, right? So if you do that, you will get two different answers. So if you put n equal to 1 into this, you will get, correct me if I'm wrong, I think you will get excuse me, uh, try 1 over psi 2, so you get k equal to 0, k equal to 1, k equal to 1 will give you I'm not 100% sure, but I think this is what you will get. Correct me if I may be wrong, but just check my answer. You should put n equal to 1. I think this is what you will get. You may want to check it. And if you put n equal to 1 here, you will get clearly this is equal to 1. You may want to check my answer. I'm not 100% sure that You may want, I think you may want to check my answer. I'm not certain really, but this is what I'm getting. Okay, and finally, to do part D, of the question, uh, which is to find the variance of x, which is given by this, right? Okay, we know what this is, so we just need to find this. So to find this, you just put n equal to 2 into this formulas, right? So this is, I think this is, again, you may want to check my answer if it is correct or not, but this is what you will get, I think. So if n equal to 2, minus the square of, yeah, that's if psi is not equal to 0. And if psi is equal to 0, then is 2 minus 1 squared, which is 1, of course, as if psi is equal to 0. All right, so once again, please check my answers here. This one and this one, I'm not 100% sure. You may want to check it again to see if that's correct. All right, any questions on this, guys? So this is the question number 2. The answer for question number 2. Hello, guys. Are you okay or not? I mean, these two questions are not really difficult, as you can see. It's just basically integration and differentiation, right? So they're not at all difficult questions to answer. Okay. Hello, guys. Are you okay? You have any questions you want to ask? There are 2 minutes left. I mean, you can contact me 24/7. But do you have any questions right now you want to ask me? Hmm? Hello, you guys talking? You're being silent now. You have any questions you want to ask me now or no? Hmm? No, no questions. Okay, good. So I mean, this is the last lesson but obviously your exam will be on Tuesday, 9 to noon. Then you will have 1 more hour to upload your answers to Blackboard. I will try to mark the exam as soon as possible, but I'm not allowed to tell you what you got in the exam. I think you will get an email from the department about your final mark for the course. But I mean, it's been really great teaching you guys. I hope you have a good semester 2. I will not be teaching you in semester 2. I'm teaching an undergraduate course in semester 2, which is the first year undergraduate. So anyway, whatever you do, guys, whatever you do in semester 2, I wish you the best. I'm sure you guys will do very well in semester 2. And if you need any help, from me, like references or anything like that, I'm happy to write references for you guys. So please contact me. I mean, anytime, 24/7. any help you need, right? So it's been really, I mean, it's been really good teaching you guys. I hope you like this course, and maybe in the future you may want to take some other course I'm teaching. Like so keep safe, and once again, best wishes with all the exams, right? Uh, okay, bye.